All right, here we go, guys. So we're going to jump ahead to example number 8 in the normal distributions. Example number 7, we're going to go ahead and skip it. As you know, Mr. Sourdough Bread tends to over-prepare. So I didn't give you a homework question like example 7, but I did give you one like 8. So let's take a look at it here. So we're told that the mean for the square footage of a home is 1,810 feet. With a standard deviation of 92, and it also mentions that the variable is normally distributed. So a particular contractor wants to build homes that will capture the middle 80% of the market. So the picture as I see it would be normally distributed with a mean of 1810. 80%, all right, if they want the middle 80%, and we looked at an example like this, I believe it was on example 2, then we talked about, well, since this is symmetrical, doesn't it make sense to put half of that on either side? Now, before I do this, though, I would change that into 0.80. And you might recall what we did is we said, why don't we put half of that on either side? So 0.80 divided by 2, 0.80 divided by 2 would be 40% on each side of the mean. Now the beauty on this picture is that you'll notice that those are both middle slivers, aren't they? And that bodes well for the table here in a minute. But speaking of the table, the thing is we can't use the table quite yet because that table only works for the standard normal. So I always like to draw the corresponding standard normal picture underneath here. Bell curve, 0 in the middle. All right, and again, the nice thing about this is, and by the way, we're looking for the two square footages that will surround the middle 80% of the market. So there's really two values of x. Let's backtrack for a second. When you have two values you're looking for, we often will say that, let's call that one x1, and we'll call that one x2, all right? So when we translate that down here, this will be z1, and this will be z2. And the beauty is, much like the picture right above it, we need to find these two z-scores that correspond to middle slivers of 40%. Now, table's ready, isn't it? Table's happy. Hey, table! I got a picture of you with a couple middle slivers that are both 40%. Table happy. Table happy. Table like middle sliver. All right, we've done enough of these. I hope we can now just talk this through. But if we go look for 40% in the body of the table, I would point out to you that the two surrounding numbers are 3997 and 4015. And it would be closer to the 3997, and that lines up with the z-score of 1.28. 1.28. So if you have a middle sliver like that, you're looking at 1.28 on the negative side and 1.28 on the positive side. All right, so those are the two z-scores that would encompass the middle 80% of the bell curve. So, but those aren't square footages, those are z-scores. So again, what we always need to do in a case like this is we need to translate those z-scores into actual square footages with our good friend the translator here. And so there's really two of them we get to enjoy now. So if we're going to determine the smallest size of house that we intend to build, that would be this one over here, right below the mean. So I'm going to write that formula up here again. Z equals x minus mu over sigma. And in the case of the lower side, let's see, the z-score would be negative 1.28. X would be the square footage we wish to determine. Mu would be the 1810, and sigma would be the 92. And then again, Mr. Snob, I guess, will now say, that's just algebra. So you would multiply both sides by 92 in order to clear the fraction. Over 1. Cancel, cancel. So we have x minus 1810 over here. And over here we take 92 times negative 1.28. All right. And I don't know that one off the top of my head, I'm embarrassed to say. But that would be, let me double check, that would be negative 117.76, and then of course we add over the 1810, it's just algebra, and so this value of x which actually would be the X1, as I labeled it there, right on the lower side. This is going to represent the smallest house that we plan to build, all right? 1,692 square feet, basically. And we'll write this all up as a pretty answer when it's all done. But that would be the lower end of it. And then on the upper end, same thing. We translate this z-score into a square footage. So, and I'll just remind you, this is always our translator. Z equals x minus mu over sigma. It allows us to converse back and forth between the two. And so that z-score is positive 1.28 equals x minus the mean of 1,810 square feet and the standard deviation of 92. All right, clear fractions. Multiply both sides by 92. 1, 2, 3 all together now. Over 1. Cancel, cancel. And over here, when we take 92 times 1.28, well, it should be the same number, except in this case, positive 117.76. And that would equal x minus 1,810. And then you add the 1,810 over and get that value of x. All right? So 1,810 added over there, plus the 117.76. I wish I could do this in my head. My brain's a little bit fried right now, maybe. I don't know. It's always fried. 1927. That's pretty cool. That's the year that I was born. All right. Please laugh. Now let's write it up here. And look, I won't make a big deal out of rounding, but I think since these are square footages of a house, let's go to the nearest whole number. And so I would say that they should try to build houses anywhere from, let's say, 1,692 square feet. That was actually the year I was born. To, let's call that 1928 square feet. That was the year I graduated high school. So if you do the math here, it took me quite a while to graduate high school. But anyway, 1,692 square feet to 1,928 square feet. That would be the range of sizes that this contractor would want to build in order to capture the middle 80% of the bell curve. I did my best. You do your best. We're all doing our best. Let's go for it.